Hey everyone, welcome back to Singularity Today. I'm Atom Infinity, and today we're going to dive into the cutting edge of artificial intelligence research. We've got a lot of fascinating breakthroughs to talk about, from making AI judges more reliable to building robots that understand human language to improving the way AI learns from data. We'll also be exploring some exciting new applications of AI in fields like medicine, climate science, and even materials discovery. So buckle up. It's going to be a wild ride. In the research titled Judge Bench, a benchmark for evaluating LM-based judges, the authors highlight the growing use of large language models, LMs, as judges to assess other ELMs. They point out that while these ELM judges are increasingly used, their own reliability is rarely examined. The research proposes a new framework for evaluating ELM judges, focusing on tasks that go beyond simple alignment with human preferences. This new benchmark, called Judge Bench, challenges judges on tasks that require knowledge, reasoning, math, and coding skills. The researchers found that even very strong ELMs like Jeep-4 perform poorly on these challenging tasks, often barely better than random guessing. The impact of this research is significant as it provides a reliable platform for testing the capabilities of LM judges, helping to ensure that their evaluations are accurate and trustworthy. This research can be beneficial for developing better LM judges, leading to more accurate assessments of ELMs and ultimately better AI systems. In the research titled Identifying Task Groupings for Multitask Learning Using Pointwise V Usable Information, the authors tackle a common challenge in multitask learning, figuring out which tasks should be grouped together for optimal performance. Imagine trying to teach a student multiple subjects simultaneously. Some subjects might be better learned together, while others might be best learned separately. Similarly, in machine learning, combining certain tasks can lead to better results, while combining others can be detrimental. The authors propose a new metric to assess task similarity based on a concept called Pointwise V Usable Information, BVEV. This metric essentially measures how much useful information a dataset provides for a specific task. They hypothesize that tasks with similar PV estimates are likely to benefit from being learned together. They tested their approach on various natural language processing tasks and found that grouping tasks with similar PV values consistently yielded competitive results, even when compared to using massive language models like Llama 2 and Jeep-4. This research offers a valuable tool for researchers and developers working on multitask learning, enabling them to make more informed decisions about task groupings. By effectively grouping tasks, they can optimize model performance, reduce model complexity, and achieve better results across various domains. In the research titled Harmon, Whole Body Motion Generation of Humanoid Robots from Language Descriptions, the researchers focus on making humanoid robots understand and respond to human instructions given in plain language. They achieve this by combining human motion data with advanced language models called vision language models. These models are like super smart assistants that can understand the meaning behind words and create realistic motions for the robot. The research shows promising results, proving that robots can now perform diverse actions based on natural language commands. This could lead to robots becoming more helpful and integrated into our lives, assisting us with tasks like chores or providing companionship. Imagine telling a robot to pour me a glass of water, and it understands and does it smoothly, just like a human. The possibilities are exciting, with applications in various fields from healthcare to manufacturing. In the research titled Vaccinating Federated Learning for Robust Modulation Classification in Distributed Wireless Networks, the authors address the challenges of automatic modulation classification, AMC, in wireless networks. They specifically focus on improving the robustness of deep neural network, DONE-based AMS models trained using federated learning, FEL. The research proposes a new FL model called Vaccine, which aims to enhance the generalization ability of AMS models by incorporating noise during training. This noise injection technique helps the model learn to handle variations in signal quality, a common problem in real-world wireless environments. Vaccine also utilizes a split learning strategy to optimize the model's learning process, enabling it to adapt to diverse data distributions across different network nodes. The experimental results show that Vaccine outperforms existing L-based AMS models in terms of accuracy and robustness to noise. This research contributes to improving the reliability and performance of communication systems in practical wireless network settings. Imagine trying to identify different types of music being played in a crowded room with lots of background noise. Vaccine is like an AI model that can filter out the noise and accurately classify the music even under challenging conditions. This advancement could lead to better network performance, more efficient resource allocation, and a smoother user experience in various wireless applications. In Open Materials 2024, OMAT 24, Inorganic Materials Dataset and Models, the researchers tackle the challenge of finding new materials with awesome properties. They believe that artificial intelligence can be a game changer in this quest. The problem is, AI needs a ton of data to learn properly, and finding publicly available training data for materials science was a huge hurdle. That's where this research comes in. They created OMAT24, a massive data set containing over 110 million calculations about different materials, along with some super smart AI models. These models, called Equiformer 2, are top-notch in terms of predicting how stable a material is and how much energy it takes to form. The research shows that the size of the model and some clever training tricks significantly improve the model's accuracy. By making OMAT24 and these models freely available, they hope to accelerate scientific discoveries. Imagine being able to design new materials for solar panels, batteries, or even new computer chips much faster. This research is like giving scientists a powerful new tool to explore the vast world of materials. In the research titled SAFREE, Training, Free, and Adaptive Guard for Safe Text to Image and Video Generation, the authors address the problem of generating unsafe content with powerful diffusion models. These models are great at creating realistic images and videos, but they can sometimes produce harmful content. The research introduces a new method called SAFREE. SAFREE doesn't change the model itself, but instead acts like a filter. It identifies specific words or phrases associated with harmful concepts within the text prompts and steers them away from those harmful areas. Think of it like redirecting a train on a track to avoid a dangerous section. SAFREE dynamically adjusts its filtering intensity to balance safety with maintaining the desired content. This means it can remove harmful elements without impacting the overall image or video quality. The research shows SAFREE works effectively in suppressing unsafe content in image generation, performing better than other methods that don't require training. This research is important because it can help make text to image and text to video models safer. Imagine a world where AI-generated images and videos are free from harmful content. This could have a huge impact on online platforms, creative industries, and even education. Potential use cases for SAFREE include protecting social media platforms from harmful content, making virtual worlds safer, and creating educational resources that are free from bias or offensive imagery. In the research titled Unitary Multi-Margin BERT for Robust Natural Language Processing, the authors address the vulnerability of natural language processing (NL) systems to adversarial attacks. These attacks can manipulate the input data to trick the system into making wrong decisions. The researchers propose a new method called UniBERT, which combines two techniques, unitary weights and multi-margin loss, to make BERT models more robust against these attacks. UniBERT significantly improves the accuracy of the model after it has been attacked, while still maintaining good performance before the attack. This means the system can withstand malicious interference better and still perform well in normal situations. This research could be very useful for developing NLP systems that are used in sensitive applications, like those in healthcare or finance where security is crucial. For example, imagine a system that analyzes patient medical records to diagnose illnesses. By making this system more robust to attacks, the researchers can ensure it provides accurate diagnoses even if someone tries to tamper with the data. In the research titled Counterfactual Generative Modeling with Variational Causal Inference, the researchers tackle the problem of predicting what would happen if someone was exposed to a different treatment, even if they didn't actually experience it. This is especially tricky when the outcome we're interested in is very complex, like a set of gene expressions or a facial image, and we have limited information about the individual. Imagine trying to predict how someone would look if they had a different hair color. You'd need more than just their current hair color to make an accurate prediction, right? This research proposes a new way of thinking about this kind of prediction using a concept called variational causal inference. Essentially, it creates a model that can learn how different treatments impact complex outcomes and then use that knowledge to predict what would happen under alternative treatments. The researchers claim that this method is better at handling counterfactual scenarios than previous approaches and show its effectiveness through experiments. This work could have significant implications for fields like personalized medicine and medical research, where understanding how different treatments affect individuals is crucial. For example, it could be used to predict how different medications might impact a patient's health, or to design personalized treatments based on individual characteristics. In the research titled Transformer-Based Super-Resolution, Downscaling for Regional Reanalysis, Full Domain V's tiling approaches, the authors explore different methods for generating high-resolution climate information from coarser data using a technique called super resolution, CRR. Imagine trying to make a blurry picture clearer by adding details. This is similar to what SISTER does with climate data. The researchers specifically looked at using SISTER for regional climate models, which are used to predict things like temperature, wind, and rainfall. They tested different methods, including a new one called SWIN Transformer, and compared them to other existing techniques. They also tried two approaches, one using the whole region at once and another using smaller tiles of the region. The results showed that the tiling approach works well for very large regions, even though it may not be as accurate as using the full region. The researchers conclude that the tiling approach is a good option for large-scale applications and is useful for real-time weather predictions. This research is important because it helps improve our ability to make accurate climate predictions for specific regions, which can help us understand and prepare for future climate changes. In the research titled Henry, a multi-agent system framework for multi-domain contexts, the focus is on building a system of collaborating artificial agents, like a team of little robots working together that can adapt to different situations within a big company in Intesa Sanpaolo. The system, called Henry, is designed to be flexible, adaptable, and able to optimize resources, much like a well-oiled machine. The researchers are exploring two key aspects: how to structure this team of agents efficiently and how to make them work together smoothly. The research emphasizes that Henry can be applied to various scenarios within similar organizations, making it a versatile solution. The impact could be a more efficient and adaptable way for companies to manage their operations, much like a well-coordinated team can achieve better results than a disorganized group. All right, that's a wrap on another mind-blowing episode of Singularity Today. I hope you enjoyed this deep dive into the latest AI breakthroughs. And remember, you don't have to take my word for it. Go check out these research papers for yourselves and form your own conclusions. I'm always on the lookout for new discoveries, so be sure to like, subscribe, and comment below with any exciting research you've come across. And hey, if you're feeling particularly creative, maybe even write a song about AI. I'm sure it'll be a hit. But seriously, don't forget to check out those papers and tell me what you think. I'm Adam Infinity, and I'll see you next time on Singularity Today. P.A.S. Did you notice this entire video was narrated by an AI? I'm not even kidding. Humans were completely uninvolved in the production of this video. You're welcome. You can now go and enjoy your free time.